The moon turns red and the sky grows quiet. And for a few brief hours, the earth reveals one of its oldest secrets. The magic of the lunar eclipse's beauty, awe, omen, myth, and its impossibly perfect geometry make you ponder the great moving forces of our universe. A lunar eclipse happens when the Earth moves directly between the Sun and the Moon. The Sun's light is usually very bright and uninterrupted, and now it is blocked by Earth's shadow, but just for a short time. Our planet casts two kinds of shadows: the penumbra, the soft outer shadow, and the umbra, the dark inner core. When the moon passes through the umbra, that is when the eclipse begins. But something unexpected happens. The moon does not disappear at the point of alignment. Instead, it glows red. But why? Sunlight travels through Earth's atmosphere before reaching the moon. Our atmosphere scatters shorter wavelengths of light, like blues and violets, and it bends longer red wavelengths around Earth's edges. The bent red wavelengths of light curve around Earth to reach the moon at totality. It is the same reason sunsets burn orange, pink, and crimson as the light curves around our horizon. During a lunar eclipse, every sunrise and every sunset from all around the world is projected onto the moon's surface at once. It's a glimpse reminder of our oneness. And the red moon is the color of all of our skies combined across the world. For most of human history, eclipses were mysteries. The word eclipse comes from the Greek eclipsis, meaning abandonment or downfall. Some civilizations saw dragons swallowing the moon, while others believed the gods were sending warnings. Imagine watching the moon fade to almost black and then blood red without knowing why. Science has now given us a deeper story and a deeper understanding. But many myths and omens still live on. In some cultures, eclipses are seen as high stakes, cosmic plot twists, or destined moments in time. But why don't we see an eclipse every month? The moon orbits Earth every month, so why isn't there a lunar eclipse at every full moon? And that is because the moon's orbit is slightly tilted at about 5 degrees relative to Earth's orbit around the sun. Most months, the moon passes just slightly above or slightly below Earth's shadow. Only when the alignment is perfect, when the sun, the earth, and the moon form nearly a straight line, does an eclipse occur. It only happens at one perfect point for the full moon and one perfect point for the new moon, which is a solar eclipse. The moon is about 400 times smaller than the sun, but also about 400 times closer to Earth. By an impossibly perfect chance of cosmic scale, the two appear nearly the same size in our sky because of this. That is why eclipses are possible at all. The geometry is nearly perfectly aligned. And here's a secret rarely talked about. Lunar eclipses may be a temporary phenomenon in Earth's long history. Someday the Earth will have its final eclipse event. The moon is slowly drifting away from Earth at about 3.8 centimeters every year. Over immense spans of time, this changes the geometry of eclipses. Not to worry though, we will get to enjoy eclipses for millions of years to come. This change will not happen anytime soon. However, the sky we inherit is not permanent and is ever changing. Even the cosmic rhythms that feel eternal are evolving in constant motion. We are lucky observers living at a precious moment when the dance still aligns. A lunar eclipse is proof that we live inside a system of motion, precision, and wavelengths seen and unseen. The moon turns red because Earth and its alignment exists, because we have an atmosphere, because sunlight bends, and because the universe follows laws beautiful enough to predict and mysterious enough to inspire. And for a few quiet hours, we get to watch our planet paint the moon.